Okay, in this module we're going to be talking about the repeated measures ANOVA test. If you'll recall, just like in the paired samples t-test that we did, if you'll recall the paired samples t-test last week, it had the same assumptions as a normal t-test, except the assumption of independence had been intentionally violated by the study design. So you were trying to test differences between two groups that were of the same people at each time. And the repeated measures ANOVA is the same way, except you can have more than 2 times or 2 groups, but it's the same people throughout. But just like the t-test, all the other assumptions for ANOVA are pretty normal. So you've got normality, homoscedasticity, and all of those other things, relatively equal cell size, that we want to be sure to have taken accounted for. Everything except the independence assumption. So we're going to go ahead and run this. If you'll recall, just like in the independent samples t-test, we don't have any variables that are what we would generally consider running this type of test for. But I'm going to show you how to do it, and we'll go over the output, and we can then talk about it a little bit. So to run this measure, we go to run this test. We go to Analyze, General Linear Model, and then into Repeated Measures. And you'll be then shown this box. You won't have Tim in there. But then you basically create your own factor of whether it would be time or something along those lines. Just like in the independent t-test, you're going to have your scores as different variables. So if you got your pre-test, post-test, and then a third post-test, or if you've got an intervening test in between 2 different treatments, then you'll just have each of those scores as independent variables. And you create a factor name, and we'll go time for this case. Yeah, we'll go time and just do it hypothetically, and we can go up to 3, as many as you want, number of levels, just depending on how many you have. But let's think of hypothetically we have a 2 treatment study with 1 measurement at the beginning, 1 measurement in between, and 1 measurement at the end. So we didn't just go add and then define. And as you can, I'm going to just click reset. As you can see, we've got 3 different factors here then that we can load in with different ones. So we'll just go seek place. You got to select that one, seek large, and then seek activity. And just like other options, you can go descriptive statistics, homogeneity tests, and we'll just throw time over there so we can get that. Estimates of effect size, observed power, just like we did with the other ANOVA tests. We'll just click OK. Okay, so homogeneity is only useful, only measured within, if they're between subjects factors, within subjects, that makes sense. You've got homogeneity already built in because they're the same. As you can see here, we've got our means. This is a different thing that we don't really need to worry about at this point, how we set up the test. We'll get more into that in MANOVAs. We'll talk more about that. This is a test of an assumption that looks to see if, well, I'm not sure off the top of my head. I've forgotten what this test does, but I know that we want it to be non-significant. So it's an assumption test to see if our data is normal, and it does some sort of transformation around it, and it basically sees if our data is okay to use in a repeated measures. This is the only time you'll come across this test of sphericity. And then so we want it to be non-significant, and that lets us know what output we can read here within. We're looking at our within subjects effects. So if we go sphericity assumed, then we can look at this top row. Since this is non-significant, we can assume sphericity. So if it was significant, we'd have to use one of these other rows as well to look at Heinfeld probably was the one I've been taught to look at. It's kind of a middle of the road. This greenhouse Geiser is really strict. Lower bound is really loose. Heinfeld is a little bit easier, about middle of the road. But as you can see, the items will always be very similar. So we will look at sphericity assumed. As you can see, our F value is really high, and that is significant. So if we were to have a test where we had those three variables measured at different times and they were the same, there would be significant group means between these variables, and as you can see, those means are quite different. So that is the repeated measures ANOVA. It's a pretty easy test. You won't come across it a lot, but there's one thing: you can't run any post hoc tests to see if there are differences, but where the differences lie between the groups. So if you wanted to see where there were differences between these three groups, you would then have to run independent samples t-test, paired samples t-test to see where the differences lie. So that's it for the repeated measures ANOVA.